Good morning, students. So today also I am doing class 12 science. The topic is differentiation of the function. So in the last class we discussed about, that is, we did the basic concepts of differentiation of the function. So in the last class we did formulae also. So you should know all the formula. Now we'll do some problems from this exercise, that is exercise 3a. So you should know all the formula that we have done in the last online class. And in class 11 also you did some formulae, isn't it? So in this case you should know the differentiation of the inverse circular function also. That is, what is d by dx of sine inverse x, what is d by dx of cos inverse x, and so on. Okay, so we discussed about the formula of this inverse circular function in the last online class. So today let's do some problems from this exercise 3a. Okay, that is page number 291. The book used here is higher secondary mathematics, higher mathematics for class 12 by SN, that is Sailendra Pradhan. Okay, so exercise 3a, each question carries 2 marks. So let's do find the derivatives with respect to x. So this is from each question carries 2 marks. Okay, so find the derivatives with respect to x. That is 7 number 1. Let's start from 7 number 1. That is 2 tan inverse x upon a is there. Okay, so let us assume it as, let y is equal to 2 tan inverse x upon a. Now in this case you have to find out the derivative of this function with respect to x. That means, or you have to find out the differentiation of this function with respect to x, or you have to find out the differential coefficient of y with respect to x. So you have to differentiate both the sides. Let us assume it as y and let us find out dy by dx. Okay, so differentiating, diff dot means differentiating both the sides with respect to x. That is, you are asked to find out the derivatives with respect to x, right? So differentiating both the sides with respect to x. So what do we get? Therefore it will be d by dx of y is equal to, here 2 is constant and 2 is with the variable, so 2 is taken outside d by dx, that is 2 into d by dx, and you have to differentiate the variable. That is, here the variables are y and x only, and all other terms other than x and a are constant. That is, in this case 2 and a are constant, but 2 is written outside d by dx, so it is tan inverse x upon a, but you cannot separate this x by a. That is, it is the inverse circular function, that is tan inverse x upon a. This x upon a, from this x upon a, 1 upon a cannot be separated. That means you cannot simplify it further, right? That means you have to get the differentiation of tan inverse x by a with respect to x. Okay, so now it is, what is dy by dx of y? It is dy by dx. That means you have to calculate dy by dx. So in the last online class I told you about the method of finding the differentiation of the function, isn't it? Now this 2 is constant, it remains same. So d by dx of tan inverse x upon a. Now how can you differentiate it? So you have to take it as, this is the differentiation of the function, isn't it? First of all, it is the inverse circular function, that is tan inverse. That is, first function is inverse circular function, that is tan inverse. And now within this inverse circular function there is another function x by a, which is an algebraic function. So in order to differentiate this function you have to take it as tan inverse x, right? So which function is taken as x? X upon a, that is algebraic function x upon a is taken as x. So let us differentiate it, d by dx of tan inverse x by a. That means you have to take it as tan inverse x to differentiate it. Okay, so now tan inverse x, what is the differentiation of tan inverse x with respect to x? You know the formula, isn't it? it is 1 upon 1 plus x square. You know this formula, isn't it? That is dy dx of tan inverse x is equal to 1 upon 1 plus x square, right? So 2 into 1 upon 1 plus x square is there, but which function is taken as x by a? But here you cannot write only x, you should take it as x by a. So x by a whole square into, now, so you have to differentiate the function which is assumed as x also. This is not the only differentiation of tan inverse x by a, but you should write here, you should differentiate the function which is assumed as x. So which function was assumed as x here? It is x by a. You have to differentiate x by a again. So into, that means you have to differentiate the function which is assumed as x. That is dy dx of x upon a. Is that clear? The यसमा हामीले यो differentiation कसरी गर्दैछौं भन्दाखेरि dy dx of tan inverse x by a. That means you have to differentiate tan inverse x by a with respect to x. Okay? So first of all, you should take this function as tan inverse x. तो पहिला हामी यसलाई के लिन्छौं? Tan inverse x ले differentiate गर्छौं. What is the differentiation of tan inverse x? It is 1 upon 1 plus x square, right? So it is 1 upon 1 plus, but what is x here? You should write x by a whole square. Okay? Now, अब के गर्नुपर्छ? जुन चाहिँ x लिएको छ त्यसलाई हामी फेरि differentiate गर्नुपर्छ with respect to x. That is x by a लाई हामी फेरि differentiate गर्छौं with respect to x. So it is written as dy dx of x by a. Is that clear now? So let us simplify it now. So or dy by dx is equal to 2 into 1 upon 1 plus, what is x upon a whole square? It is x square upon a square into, now how will you differentiate dy dx of x by a? Now which is constant out here? 1 upon a. 1 upon a, it is taken outside because this is constant term. Only you have to differentiate the variable, that is dy dx of x. That is x is to be differentiated with respect to x. So what will you do with 1 by a? It should be taken outside dy dx. Okay? So it is 1 by a into dy dx of x. Now what is dy dx of x? It is always 1, you know that, isn't it? Or dy by dx, let us simplify it. Dy by dx is equal to 2 into 1 upon, what's the LCM out here? It is a square. So it is a square plus x square. Is that clear? That is a square is the LCM. So what will be above this denominator? Above this denominator a square, there will be a square into 1. A square plus x square, right? So into 1 upon a into, what is dy by dx of x? Always 1. So write 1. Okay? So here you can simplify it. A and square gets cancels. Or what is the value for dy by dx now? So dy by dx is equal to, now a goes up in the numerator. So when this a square plus x square by a goes up in the numerator, it becomes upside down. That is 2a divided by a square plus x square. So is that clear to all of you? So this is your answer. So what is the differentiation of 2 into tan inverse x by a? It is 2a whole divided by a square plus x square. So this is the answer. Is that clear? So we'll do the next question now. You can copy it. Now we will do the next question, that is 7 number 2. You have to find out the derivatives with respect to x of the function log of within bracket cot inverse x. So let us assume y is equal to log of cot inverse x. Let us find out dy by dx. That is, you have to differentiate both the sides with respect to x. So differentiating both the sides with respect to x, right? So therefore dy by dx is equal to dy dx of, it is log of within bracket cot inverse x, right? So or dy by dx is equal to, now how will you differentiate it with respect to x? That is, you have to differentiate log of within bracket cot inverse x with respect to x. Okay, so first of all, which function is given out here? Log. This is logarithmic function. It is just like your log x. So how will you differentiate it now? You have to take it as log x form. You know the differentiation of log x. What is the differentiation of log x with respect to x? It is 1 upon x. So this cot inverse x is assumed as x. So what is d by dx of log x? It is 1 upon x. So 1 upon, but you can't write here x. But what was the value for x? It is cot inverse x. Okay. So this is not the only differentiation of log of cot inverse x. Also, in this case, you have to differentiate the function which is assumed as x. So in this case, which function is assumed as x? It is cot inverse x. This function is also to be differentiated. That is into d by dx of cot inverse x. Okay. So in the last online class, we did the formula of d by dx of cot inverse x, isn't it? So you should know this formula, right? So d by dx of cot inverse x is equal to what? Is equal to, it starts from c, so minus 1 upon 1 plus x square, right? So now let us write down here. So this is the formula. This is the formula, right? So therefore dy by dx, so dy by dx is equal to 1 upon cot inverse x, 1 upon cot inverse x into, what is d by dx of cot inverse x? It is minus 1 upon 1 plus x square, right? So this is the answer. Let us simplify it further. So how to write it? So dy by dx is equal to, minus sign is taken outside, okay? So 1 ones are 1 divided by, let us write it first, that is 1 plus x squared first, then write down cot inverse x. Okay, so this is the final answer. So I think you have understood it. Okay, so these are the basics of differentiation of the function that you should know. So we'll do the next question now. So now we'll do the next question, that is 7 number 3. You have to find out the derivatives with respect to x of the function sec within bracket tan inverse x. So let us assume y is equal to sec tan inverse x. That means you have to find out the derivative of y with respect to x. That means you have to find out dy by dx, right? But in this case, this is the problem of inverse circular function, that is sec tan inverse x. Okay. Now in this case, this sec within bracket tan inverse x can be simplified further, as you know in the chapter inverse circular function. So this type of function can be simplified further, right? Let us simplify it first with the help of inverse circular function. So this is tan inverse x, this is an angle, you know that, isn't it? So this tan inverse x, you should assume it as theta first, okay? Let tan inverse x is equal to theta, right? So when this tan inverse goes to the right hand side, becomes tan theta. So x is equal to tan theta, or you can write tan theta is equal to x. You may write tan theta is equal to x, or x is equal to tan theta, right? Now this y now becomes, therefore y is equal to sec. What is tan inverse x now here? Tan inverse x here is theta, right? But you should write this sec theta in terms of x, because in the question it is given in terms of x. So you should write down sec theta in terms of x. That will be the simplified value of sec within bracket tan inverse x. Okay. But we know tan theta is equal to x. So convert this sec theta into tan theta. You know the formula. Or y is equal to, what is sec theta in terms of tan theta? Root over 1 plus tan squared theta. Right. So therefore y is equal to, now you can put the value for tan theta. What is the value for tan theta here? It is x, right? So y is equal to root over, this is your 1 plus x squared. Is it clear to all of you? That is, this sec within bracket tan inverse x is simplified. And what is the value for sec within bracket tan inverse x? The simplified form is root over 1 plus x square. Now you can easily differentiate this function with respect to x. Okay, so let us differentiate it. So you have to write down differentiating both the sides. Differentiating both the sides with respect to x. Okay, so therefore it is dy by dx is equal to dy dx of within bracket root under 1 plus x square. So left hand side, write down dy by dx. dy by dx is, now how can you differentiate dy by dx of within square root 1 plus x square? Which function will you assume as x, right? You cannot take within root 1 plus x square as x, because dy by dx of x is always 1. But that square root differentiation of square root is not 1, right? So which function is taken as x here? How will you differentiate it? That is, you should take it as dy by dx of root over x. You know the differentiation of root over x with respect to x, isn't it? So you did it in class 11, I think, right? So what is dy by dx of root over x? It is 1 by 2 root over x. You know this formula, isn't it? That is dy by dx of root over x is equal to 1 by 2 root over x. You should know this formula, right? What is dy by dx of root over x? It is 1 by 2 root over x. Okay. So now, in this particular problem, which function is taken as x? 1 plus x square is taken as x. That is, it is root over x, right? So what is this differentiation? 1 upon 2 root over 1 plus x square into. So यसको डिफरेन्सिएसन यति मात्र होइन है, कुन चाहिँ फंक्सनलाई हामीले x सम्झेर यसलाई डिफरेन्सिएट गरेको हो 1 plus x square लाई, त्यसलाई फेरि हामी के गर्नुपर्छ? डिफरेन्सिएसन गर्नुपर्छ, ठीक छ? त कसरी लेख्छ? So dy by dx of within bracket 1 plus x square. Is that clear now? So or it is dy by dx is equal to 1 upon 2 root over 1 plus x square into, let us write it within bracket. Now what is dy by dx of 1 plus x square? You can find out the differentiation of the first term plus differentiation of the second term, right? So what is dy by dx of 1? 1 is constant, you know that, isn't it? What is dy by dx of constant term? 0, you know that. It is 0 plus, next it will be dy by dx of x square. It is just like dy by dx of x to the power n. What is dy by dx of x to the power n? N comes in the front, then x to the power, decrease the power by 1. That is x to the power n minus 1. So similarly, here also, the power comes in the front to x to the power, decrease the power by 1. That is 2 minus 1. That is 1. So, power 1, so usually we don't write it. Okay? That is x to the power 1 is only x. Is that clear to all of you? So, or it is dy by dx is equal to 1 upon 2 root over 1 plus this is x square into, what is 0 plus 2x? It is 2x. So here 2 gets cancels. So what is the final answer now? X upon, it is root over 1 plus x square. This is root over, right? So this is your final answer. So I think you have understood it. You can copy it. So we'll do the next question now. So now we will do the next question, that is 8 number 1, right? So what is 8 number 1 here? You have to find out the derivatives with respect to x of the functions 2 sec inverse 2x minus 3 sin inverse x plus cos inverse x square. So you have to find out the derivative of all these three functions given here. Okay? So let us assume let y is equal to. Let us find out derivatives. Okay? So differentiating both the sides both the sides with respect to x, right? So therefore dy by dx is equal to 2 is constant. So you should write 2 before d by dx, right? So dy dx of sec inverse 2x minus 3 into dy dx of sine inverse x plus, next, it is dy dx of within second bracket, it is cos inverse x square. Now how will you differentiate the first function, that is sec inverse 2x, right? Or dy by dx is equal to 2 into, now first of all it is given sec inverse. So you have to find out the differentiation of sec inverse x first. Which function is taken as x? 2x, right? So what is dy by dx of sec inverse x? You should know it. dy by dx of sec inverse x, what is the formula? dy by dx of sec inverse x is equal to, what is the formula here? It is 1 upon x root over x square minus 1, right? So let us take it as dy by dx of sec inverse x. Which function is taken as x here? It is 2x. Now let us differentiate it first. 2 into 1 upon, what is x here? It is 2x, right? So it is 2x, instead of x there is 2x, you should write instead of x 2x here. Within square root, what is x whole square? It is 2x whole square minus 1. Is that clear? So we are using this formula here, but instead of x there is 2x. But this is not the only differentiation here. You should differentiate the function which is assumed as x. हामीले कुन चाहिँलाई x मानिलिएको छौं एकछिनको लागि 2x, त्यसलाई फेरि हामीले डिफरेन्शिएट गर्नै पर्छ. So dy by dx of 2x, right? Is that clear now? So minus 3 into second term now. It is directly given dy by dx of sine inverse x. What is the differentiation of sine inverse x? It is directly written root over 1 upon root over 1 minus x square. So in this case, you can ask me a question here. Why this x is not differentiated? We have written only here 3 into 1 upon root over 1 minus x square. In this case, sec inverse 2x is there. I have written here 1 upon 2x root over 2x square minus 1. Again 2x is differentiated. Again this 2x is differentiated, right? Again this 2x is differentiated. That is d by dx of 2x. But in this case, I have written here 3 into d by dx of sine inverse x is 1 upon root over 1 minus x square only. But you don't have to differentiate this x with respect to x, because you know that differentiation of x with respect to x is always 1. That's why x मात्रै छ भने चाहिँ हामीले डिफरेन्शिएट गर्न पर्दैन त्यसलाई. बुझ्यो? डाइरेक्टली साइन इन्भर्स x को डिफरेन्शिएसन कति हुन्छ? 1 upon root over 1 minus x square. Is that clear now? So next, plus. Now what is the differentiation of cos inverse x square? So now in this case you should take it as cos inverse x now. Which function is taken as x here? It is x square. So what is this differentiation? It is cos inverse minus. So minus 1 upon root over 1 minus x square. 1 minus, what is x here? It is x square. So you should write here x square whole square. Right? X square whole square. Because in this case, instead of x, what is there? It is x square. So into what should you write here? Again you have to differentiate the term which is assumed as x. In this case, x square was assumed as x. This is also to be differentiated. You have to differentiate this x square also into d by dx of what? It is x square. So I think you have understood it now. So this is known as differentiation of the function right? So let us write down simplified form, or dy by dx is equal to, so here these 2 gets cancels, 1 upon x root over, what is 2x whole square? It is 4x square minus 1 into, what is d by dx of 2x? 2 is taken outside d by dx, and what is d by dx of x? It is always 1. So you don't have to write it. Okay, only 2 is there. Minus, this is 3 ones are 3 divided by root over 1 minus x square, right? So plus and minus. So it is plus and minus is minus. So 1 upon this is root over 1 minus what is x square whole square? It is x to the power 4 into what is d by dx of x square? 2 comes in the front and decrease the power of x by 1. That is x to the power 2 minus 1. That is only x. So is that clear? So now next, let us simplify it further. So our dy by dx is equal to, this is 2 by x root over 4x square minus 1. This is the first term. Then minus 3 upon root over 1 minus x squared minus what is the last term here? 1 into 2x is 2x divided by root over 1 minus x to the power 4. So this is the final answer. Okay, so you can copy it. Now we will do the next question, that is step number 3. You have to find out the derivatives of cos inverse x plus cos inverse root over 1 minus x square with respect to x. Now let us assume y is equal to cos inverse x plus cos inverse root over 1 minus x square. So let us simplify it first, then differentiate. Okay, you can simplify this inverse circular function. So how can you simplify it? So how can we simplify it now? So there is cos inverse root over 1 minus x square. In this case, you should do the trigonometric substitution. So trigonometric substitution is very important method. Okay. If it is root over 1 minus x square, right? So if it is root over 1 minus x square, and if you want to substitute the trigonometric function of x, so what should you substitute for x? That is, x is equal to, either you can put sine theta or it may be cos theta. Because you know that if you put x is equal to sine theta, it will be root over 1 minus sine square theta, which is equal to cos theta. If you put x is equal to cos theta, it will be root over 1 minus cos square theta, which is equal to sine theta. That is the formula from trigonometry, right? There might be 1 plus x square also. In this case, what should be the trigonometric substitution here? If it is root over 1 plus x square, you can put either x is equal to tan theta or it may be cot theta also. Suppose if you put x is equal to tan theta in this case, so root over 1 plus tan square theta. What is 1 plus tan square theta? Sec theta. It is sec square theta. What is root over sec square theta? That is sec theta only. You can put x is equal to cot theta also, because you know that if you put x is equal to cot theta here, 1 plus cot square theta is there, and its formula is cosec square theta. And what is the square root of cosec square theta? It is cosec theta. Is that clear? You might have this expression also, x square minus 1. So what should be the trigonometric substitution here if it is root under x square minus 1? So either you can put x is equal to sec theta or you can put cosec theta. So why are we substituting sec theta for x here? Because you know that if you put x is equal to sec theta, it will be root over sec square theta minus 1. What is sec square theta minus 1? Tan square theta. What is square root of tan square theta? It is tan theta. If you put x is equal to cosec theta, so root over cosec square theta minus 1. What is cosec square theta minus 1? It is cot square theta. What is square root of cot square theta? It is cot theta. Okay? So you should know this method also. Sometimes we may use this method also. Okay? If there is root over 1 minus x squared, you put either x is equal to sin theta or cos theta. If it is root under 1 plus x squared, you put either x is equal to tan theta or cot theta. If it is root over x squared minus 1, you put either x is equal to sec theta or cosec theta. So is that clear now? So let's do this problem here. Now this is root under 1 minus x squared. You can put here either x is equal to sine theta or cos theta because it is root over 1 minus x squared. So let us put x is equal to sine theta. So let us write let x is equal to sine theta. Okay. Let us get the value for theta. What is the value for theta here? It is sine inverse x. So in this case, we have got the value for theta. Theta is equal to sine inverse x. We may or may not put the value for theta is equal to sine inverse x here. Okay. We may put sine theta is equal to x also. We may put theta is equal to sine inverse x also. So it depends upon the problem. Okay. So let us put x is equal to sine theta here. Okay. So or y is equal to, now this is cos inverse within bracket. What is the value for x out here? It is sine theta, right? Plus cos inverse root over 1 minus, what is x square now? It is sine square theta, right? It is sine square theta, okay? Or y is equal to, now this is cos inverse sine theta. So in order to simplify this cos inverse sine theta, you have to convert this sine theta into cos theta. So how can you change it? You can't write root over 1 minus cos square theta, but you can write here cos of 90 minus theta. You know that cos of pi by 2 minus theta is sine theta, isn't it? So you should write here cos inverse cos of within bracket pi by 2 minus theta, right? Plus cos inverse, now you know this formula, root over 1 minus sine square theta. What is it? So root over 1 minus sine square theta is cos theta. Is that clear? So or y is equal to, now you know from inverse circular function, cos inverse cos of pi by 2 minus theta is what? It is pi by 2 minus theta plus, what is cos inverse cos theta? It is theta. Is it clear now? So minus theta plus theta gets cancels. So what do we get here? हाम्रो simplified form के आयो? That is y is equal to pi by 2, which is always constant. तो इसको value कति रहेछ? Cos inverse x plus cos inverse root under 1 minus x square भनेको कति हो? Pi by 2. So in inverse circular function, I told you the formula of cos inverse root over 1 minus x square, isn't it? Which is equal to sine inverse x, right? And what is sine inverse x plus cos inverse x? That is also pi by 2. Directly we could have written here sine inverse x, and sine inverse x plus cos inverse x is equal to pi by 2, right? So in this, you can use this method also, okay? So we have got y is equal to pi by 2. So it is easier for you to differentiate this pi by 2, isn't it? This pi by 2 is constant. So what is this differentiation? 0. So the answer should be 0 here. So let us write here, differentiating both the sides with respect to x. So therefore dy by dx is equal to dy dx of pi by 2, right? So what is dy dx of pi by 2? It is 0. So or dy by dx is equal to, what is the answer? The answer is 0. Is that clear now? So I think you have understood it. So you can copy it. We'll do the next question now. So now we will do question number 9, number 1. Okay. So the function is given here is within second bracket f of x whole to the power n. This is function of x, right? You have to find out the derivative of within second bracket f of x whole to the power n with respect to x, right? So let us assume it as y. Let y is equal to within second bracket f of x whole to the power n. So let us differentiate it. So differentiating both the sides with respect to x. So therefore it is dy by dx is equal to dy dx of within third bracket within second bracket f of x whole to the power n, then third bracket is closed. Now how will you differentiate it? So you should take it as x to the power n. Which is the variable here? F of x. That variable should be taken as x. So it is the form x to the power n. Now you know the differentiation of x to the power n with respect to x, which is equal to n into x to the power n minus 1. You know that, isn't it? That is dy dx of x to the power n is equal to n into x to the power n minus 1. But what is x here? This f of x is assumed as x, right? So or dy by dx is equal to, now this is the form x to the power n. What is the differentiation? N into x to the power n minus 1. But out here it is n becomes the coefficient within second bracket. What is x out here? X is actually f of x. You should write f of x second bracket close whole to the power n minus 1. Now in this case you have to differentiate the function which is assumed as x. So which function is assumed as x here? It is f of x. Again, differentiate into dy dx of f of x. So what is the formula for dy dx of f of x? You know that it is f dash of x. We have done it in class 11, right? What is dy dx of f of x? It is f dash of x. What is the differentiation of f dash of x? It is f double dash of x, right? So therefore dy by dx is equal to, so it is n into, you cannot simplify this function further, keep it as it is, okay? So within second bracket f of x second bracket closed whole to the power n minus 1 into, what is dy by dx of f of x? It is f dash of x. Is it clear to all of you now? So this is your answer. So I think you have understood it. So you can copy it. We'll do the next question now. So now we are doing question number 9.2. You have to find out the derivative of e to the power phi of x with respect to x. Phi of x is also a function of x. So usually we take function of x as f within bracket x. This phi of x is also a function of x. G of within bracket x is also a function of x, right? This is also e to the power phi of x. Phi of x is a function of x. Now how will you differentiate it? Okay, so let us write down differentiating both the sides with respect to x. Okay, so therefore dy by dx is equal to d by dx of, write it within second bracket, e to the power phi of x. Okay, so or dy by dx is equal to, now how will you differentiate e to the power phi of x with respect to x? Now first of all, it is an exponential function. If it is exponential function, you should take it as e to the power x, because you know the differentiation of e to the power x, isn't it? So that is d by dx of e to the power x is equal to e to the power x. So let us take it as e to the power x. Now which function is taken as x? Phi of x, right? So this is the form e to the power x. So what is the differentiation of e to the power x? Formula e to the power x. E to the power, but in this case, what is x here? It is phi of x into. Again, you have to differentiate the function which is assumed as x, isn't it? That is, phi of x is also to be differentiated. That is, d by dx of, this is phi of x. Okay, so what is the differentiation of phi of x? It is also phi dash of x. You just have to put in the power dash. What is the differentiation? G of x, g dash of x. What is the differentiation of phi of x? Phi dash of x, right? So therefore, so this is the formula, right? So therefore dy by dx is equal to, this is e to the power phi of x into, what is dy by dx of phi of x? It is phi dash of x. x, right? So this is the final answer. So this is your answer. So now we'll do the next question. So now we are doing question number 9.3. Find the derivative of log within second bracket, again within square root f of x, second bracket is closed, with respect to x. So let us write here, let y is equal to log of within second bracket and within square root, it is f of x, right? So now you should know the properties of logarithm. So we have done it in class 11 also. Properties of logarithm. Let us revise it. Suppose this is your number 1, log of AB. What is the logarithm of the product of two numbers? It is equal to sum of their logarithm. That is log A plus log B, right? So this property is true not only for the product of two numbers, but it is true for the product of more than two numbers. If you have log of ABC, then log A plus log B plus log C. If you have log of ABCD, then you can write log A plus log B plus log C plus log D and so on, right? So this is property number 1, and number 2 is log of within bracket A by B is equal to, what is it? It is logarithm of the quotient of two numbers is equal to difference of their logarithm. That is, it is log A minus log B, right? And the next one is log x to the power n. What is log x to the power n? It is n log x. That is, n becomes the coefficient, then it is log x. Okay? So if there is no base here, you should write it as base as e. Right? And number 4 is e to the power log x base e. These two are same. This is a and this base is e. So which is equal to, this is x. That is, e to the power log x base e is equal to x. So these are the properties of logarithm that you should know, right? So now in this case, it is square root of f of x. What do you mean by square root? It is whole to the power half, isn't it? Or y is equal to log. Now we can write within second bracket f of x, second bracket closed, this is whole to the power half. That is square root of a means a to the power half. Similarly, what is square root of f of x? It is f of x whole to the power half. Now we can use properties of logarithm. This property is used, that is log x to the power n base e is equal to n comes in the front, that is n log x, and here the base is e. You can write here, sorry, this is log a minus log b, right? If there is no base there, that is the base is e. Okay? So if there is no base here, the base is e. You don't have to write base e. Okay? So now you can use problem number 3 here. That is log x to the power n base e is equal to n log x base e. The similarly here also half comes in the front because of this log. Or y is equal to, this is half log within second bracket, it is f of x. Okay? So let's do the differentiation now. Now we have to find out dy by dx, right? So differentiating both the sides with respect to x. Okay? Now we have to differentiate both the sides with respect to x. So it is dy by dx is equal to, now this half is with the variable, so you should write half before d by dx. So half into d by dx of within third bracket log of within second bracket, it is f of x. Okay? So how would you differentiate log within second bracket f of x? You should take it as log x, right? So what is the differentiation of log x? It is 1 upon x. But what is x here? It is f of x. Now which function is taken as x? It is f of x, or dy by dx is equal to half into, what is dy by dx of log of f of x? It is just like your log x. What is the differentiation of log x? 1 upon x. But what is x here? It is f of x. So 1 upon f of x into, again you have to differentiate the function which is assumed as x. Which function is assumed as x here? That is f of x. So into dy dx of f of x, right? So what is dy dx of f of x? It is f dash of x. Or it is dy by dx is equal to half into 1 upon f of x into, what is dy dx of f of x? It is f dash of x, right? So this is your f dash of x. So or dy by dx is equal to, so what is the final answer now? It is f dash of x divided by twice f of x. So this is the final answer. So I think you have understood it. So you can copy it. We'll do the next question now. So now we will do question number 9.4. You have to find out the derivative of 3 to the power u of x with respect to x. This u of x is also a function of x. This is another way of writing the function of x, f of x. It is just like your f of x. Instead of f, there is u of x. Okay. So let us differentiate it. Let y is equal to 3 to the power u of x. So write down differentiating both the sides with respect to x, right? So therefore dy by dx is equal to dy dx of, within second bracket, 3 to the power u of x, right? So you should take the differentiation of 3 to the power u of x. 3 is constant, you should take it as a, and u of x is the variable, you should take it as a to the power x. So which function is assumed as x? U of x. So this is your a to the power x. So what is the differentiation of a to the power x with respect to x? Dy dx of a to the power x is equal to, what is the formula? It is a to the power x into log a base e, right? So instead of a there is 3, and instead of x there is u of x, right? So we can use that formula here. So or dy by dx is equal to, what is the formula? This is just like a to the power x. So a is 3 and x is u of x. You should write u of x instead of x. Then log a base e. Log, what is a here? Log 3 base e. Into, again you have to differentiate the term which is assumed as x. So which function, which term is assumed as x? That is u of x. That is into dy dx of u of x, second bracket is closed. Is that clear now? So this is the formula, right? So therefore dy by dx is equal to 3 to the power u of x into log 3 base e into, what is dy by dx of u of x? You just have to put dash. That is u dash of x. That is, it is u dash of x. Okay. So or you may write here dy by dx is equal to, you can write this u dash of x in the front into 3 to the power u of x into, this is your log 3 base e. So that is the final answer. Is that clear? So we'll do next question now. Now let's do the next question, that is number 8. So find the derivatives with respect to x. That is, the function given here is tan inverse phi of x. So let y is equal to tan inverse phi of x. Okay. So let us write differentiating both the sides with respect to x. Differentiating both the sides with respect to x. Okay. So therefore dy by dx is equal to, this is dy by dx of, within third bracket, it is tan inverse within second bracket phi of x. So here third bracket is closed, right? So in order to differentiate it, so what will you take it as? So first of all, which function is given? Inverse circular function is given, isn't it? First of all, inverse circular function is given. You should take it as tan inverse x. What is the differentiation of tan inverse x? 1 upon 1 plus x square. Now which function is taken as x? It is phi of x. Okay. So so dy by dx is equal to KLHS differentiation 1 upon 1 plus x square. 1 upon 1 plus, but you can't write x square here. Instead of x, there is phi of x. You should write here phi of x whole square, right? Into, again you have to differentiate the function which is assumed as x. Which function is assumed as x? Phi of x. Differentiation. That is d by dx of phi of x. Is that clear now? So what is the differentiation of phi of x? You know that it is phi dash of x, isn't it? So therefore dy by dx is equal to, what is the differentiation of phi of x with respect to x? It is phi dash of x. What is phi dash of x? Into this one, phi dash of x. So let us write phi dash of x whole divided by what? It is 1 plus within second bracket, it is phi of x whole square. So this is the final answer, right? So you can copy it. Now we'll do the next question. Now we are doing question number 10, number 1. The question is, find the derivatives of 2x square plus 3 whole to the power 4 with respect to x. So here also let us assume y is equal to 2x square plus 3 whole to the power 4. Okay. So let us differentiate it. Differentiating both the sides. Differentiating both the sides with respect to x. Okay. So therefore dy by dx is equal to d by dx of 2x square plus 3 whole to the power 4. Right? Or dy by dx is equal to, now how will you differentiate it? Which function is taken as x to differentiate it? So first of all, it is 2x square plus 3 is the first function here. So 2x square plus 3 you should take it as x. So it is x to the power 4. So which function is taken as x? It is 2x square plus 3. That is the expression within whole to the power 4 should be taken as x. That is, it is your x to the power 4. You can easily differentiate it. What is the differentiation of x to the power 4? It is 4x cube, right? So what is dy by dx here? Now it is just like your x to the power n. Now what is the differentiation of x to the power n? N into x to the power n minus 1. So here also 4 comes in the front. 4 already. What is x here? You can't write x here, but what is the value for x? You can write here 2x square plus 3 whole to the power. You have to decrease the power by 1. That is 4 minus 1 is always 3. So now also you have to differentiate the function which is assumed as x. So which function was assumed as x? It is 2x square plus 3. Differentiation into d by dx of 2x square plus 3. Right? So let us simplify it now. Or dy by dx. So dy by dx is equal to 4 into 2x square plus 3 whole cube. Right? And then within second bracket, let us differentiate it. What is d by dx of 2x square? 2 is constant, 2 comes in the front, into, what is d by dx of x square? Here 2 is constant, isn't it? So you should write 2 before d by dx. So 2 into, what is d by dx of x square? 2x, you know that, into 2x. Plus, what is d by dx of 3? This is the only constant term there, that is 3 is the only constant term there. You should write it as plus d by dx of 3. But what is dy dx of 3? That is constant. It is always 0. Second bracket is closed, right? So or dy by dx is equal to 4 into 2x square plus 3 whole cube into 2 into 2x is 4x. What is 4x plus 0? It is 4x. So or what is dy by dx is equal to now? This is proposed as 16x into 2x square plus 3 whole cube. Understood now? So this is your answer. So you can copy it. Again we'll do the next question. So now we'll do the next question, that is 10 number 3. It is given that y is equal to 1 upon px plus q. You have to find out the derivative of this function with respect to x. Now, since the constant is, since the numerator is constant, here the numerator is constant, okay? But only denominator is the variable here. You can take this variable to the numerator. So what does it become? If you have 1 upon x, when this x goes up in the numerator, it becomes x to the power minus 1. That is your x inverse, right? So similarly, so when this px plus q goes up in the numerator, it becomes px plus q whole to the power minus 1. So now we can easily differentiate it as a differentiation of the function, right? So right now, differentiating both the sides with respect to x, okay? So therefore dy by dx is equal to dy dx of px plus q whole to the power minus 1, right? So in order to differentiate px plus q whole to the power minus 1, what should you take it as? Whole to the power minus 1 is there. It is a constant quantity. You should take it as x to the power n first. Okay? So which function is taken as x? It is px plus q. Is that clear? So it is in the form x to the power n. So you know the differentiation of x to the power n with respect to x, which is equal to n into x to the power n minus 1. Is that clear? So let us find out the differentiation now. So dy by dx is equal to, so what is the differentiation of x to the power n? N comes in the front, power comes in the front, that is what is the power here? Minus 1. Then what is x here? Px plus q. Px plus q is assumed as x. Then whole to the power, you have to decrease the power by 1. That is minus 1 is decreased by minus 1. That is minus 1 into what? Again you have to differentiate the function which is assumed as x. So which function is assumed as x? Px plus q. That is also to be differentiated. That is d by dx of, it is px plus q. Is that clear? So or now it is dy by dx is equal to minus 1 into px plus q whole to the power minus 2 into, what is dy by dx of px? So here p is constant, but p is with the variable x. So you can write p outside d by dx. So p into, what is d by dx of x? Only you have to take the differentiation of the variable. That is d by dx of x is always 1. Plus, what is d by dx of q? Q is the only term out there. Q is the constant, you know that. And what is d by dx of q? It is always 0. So put it within bracket, okay? Or dy by dx is equal to, so here it is minus, so here it is 1. You can take that px plus q whole to the power minus 2 to the denominator. The whole to the power minus 2 छ भने त्यसलाई हामी डिनोमिनेटरमा लगेर पावरलाई चाहिँ हामी पोजिटिभ बनाउँछौं. डिवाइडेड बाइ कति भयो? px plus q whole square into into what? Within bracket p1s are p plus 0, that is p only, right? So what's the final answer now? So dy by dx is equal to minus p divided by this is px plus q whole square. So this is the final answer. Now let's do the next question now. So now we'll do the next question, that is 10 number 5. So you have to find out the derivative of e to the power 2x whole to the power 4 with respect to x. So let y is equal to e to the power 2x whole to the power 4. So how will you simplify it? Or y is equal to e to the power, how can you simplify it? Whether it is e to the power 16x to the power 4 or e to the power 8x. So what is the simplification? So e to the power 2x whole to the power 4 means you have to multiply these two numbers. That is 2x into 4. What is it? 8x. Like if we have e to the power 2x whole to the power 4. Whole to the power 4 means e to the power 2x is multiplied how many times? 4 times, isn't it? So it's equal to e to the power 2x into e to the power 2x into e to the power 2x into e to the power 2x, right? So if all these terms are multiplied, what happens to the powers? Powers will be added, right? So e to the power 2x plus 2x plus 2x plus 2x, which is equal to e to the power what? 8x. That's why e to the power 2x whole to the power 4 means you have to multiply these two powers, that is 2x multiplied by 4, which is equal to 8x. Is that clear? So now you can easily differentiate both the sides with respect to x, isn't it? So write down differentiating both the sides with respect to x. That is dy by dx is equal to dy dx of e to the power 8x. Okay. So next, therefore dy by dx is equal to. So how can you differentiate e to the power 8x with respect to x? What should you take it as? First of all, exponential function is given. That means e to the power x, right? Which function is taken as x? 8x. So it is e to the power x. What is the differentiation of e to the power x? E to the power x, isn't it? But here you should write e to the power 8x into, again, the function which is assumed as x, it is also to be differentiated. You have to differentiate the function which is assumed as x, that is d by dx of 8x. Is that clear? So, or it is dy by dx is equal to e to the power 8x into, what is d by dx of 8x? Since 8 is with the variable, 8 comes in the front, that is before 8 comes in the front, that is before d by dx. So 8 into this is d by dx of x. So now what is d by dx of x? It is always 1, right? So or dy by dx is equal to 8 comes in the front, 8 into e to the power 8x into d by dx of x is always 1. So what is the final answer? That is dy by dx is equal to 8 e to the power 8x. So this is your final answer. Is that clear? So we'll do the next question now. So now let's do the next question. That is step number 12. Find the derivatives of log x with respect to x. So first of all, this function is logarithm function. Within logarithm function there is another function that is also logarithm function. Again within logarithm function there is another function which is also logarithmic function. This is known as function of the function of the function, but actually we don't say function of the function of the function, just we say function of the function, right? So let us differentiate this function of the function type question, right? So let y is equal to log, within second bracket log within first bracket log x, first bracket close, second bracket closed. So let us differentiate it, differentiating both the sides with respect to x. So therefore dy by dx is equal to dy dx of within second bracket log of within second bracket log of log x, second bracket closed, third bracket closed. So in order to differentiate this function, given function, what should you take it as? Dy by dx of log x. Log x. You should take it as log x. Right? Dy by dx of first function here is log. So you should take it as dy by dx of log x. Now which function is taken as x? Log of log x. Right? So which function is this one? Log x. What is the differentiation of log x? 1 upon x. But what is x here? Log of log x. Right? So here dy by dx is equal to, this is the form log x. Differentiation of log x is 1 by x. 1 by, what is x out here? It is log of log x. That is 1 by x. 1 by log of log x. Now which function is taken as x? Log of log x. You have to differentiate the term which is assumed as x. That is, log of log x is also to be differentiated. That is into d by dx of log x. Is that clear now? So let us differentiate it again. So or dy by dx is equal to 1 upon, so this is log of log x. This is log of log x into. Now, what is d by dx of log x? D by dx of log x. What should you take it as? Log x again. Which function is taken as x? Log x. Right? So, what is the differentiation of log x again? It is 1 by x. So, into 1 by, what is x out here? It is log x. Now, log x is taken as x. So this log x is also to be differentiated. Now you have to differentiate the term which is assumed as x. So in this case log x is assumed as x. The log x I am very careful, so differentiate. Into what? It is d by dx of log x. Is that clear now? So I think you have understood it. So or dy by dx is equal to 1 upon log of log x into 1 upon log x into, what is d by dx of log x? This is the final differentiation. What is d by dx of log x? It is 1 by x. Right? So write down the final answer now. So what is dy by dx here? Is equal to, in the numerator, 1 1s are 1, 1 1s are 1. So 1 divided by, first of all you write x, then write down only log x, then write down log of log x, then log of log x. Is that clear now? So this is very, very important question. So now we'll do the next one. So now let's do question number 13. That is, this is question number 10, 13. Find the derivatives of 10 to the power log cos x with respect to x. Let us assume y is equal to 10 to the power log cos x. So let us differentiate it. Differentiating both the sides with respect to x. Okay. So therefore dy by dx is equal to d by dx of within bracket 10 to the power log cos x. Okay. So or dy by dx is equal to. So in order to differentiate it, what should you take this function as? 10 to the power log cos x time. Since 10 is constant, you should take it as a, and log cos x. X is here, so this is a variable x. So 10 to the power log cos x, you should take it as a to the power x, right? So you know the differentiation of a to the power x. What is d by dx of a to the power x? You know that it is, what is d by dx of a to the power x is equal to a to the power x log a base e. But in this case, what is a? It is 10. What is x? Log cos x. So use that formula here. What is a here? 10. What is x? Log cos x into, what should we write? What should we write? Log a base e. What is log a base e here? It is log 10 base e into. Now you have to differentiate the function which is termed as x. I mean, x minus log of cos x the x minus lego. Differentiation. That is d by dx of log of cos x. Is that clear? So this is the formula that we are using here. Okay. So therefore dy by dx. So dy by dx is equal to, this is 10 to the power log cos x into log 10 base e, log 10 base e into. Now, how do you differentiate d by dx of log of cos x? What should you take it as? Log x. First of all, it is log, isn't it? So you should take it as log x. So what is the differentiation of log x? 1 upon x. But here, instead of x, there is cos x. So you should write 1 upon, instead of x, you should write cos x. Now, which function is taken as x here? Cos x. You should differentiate the term which is assumed as x. That is, cos x is also to be differentiated with respect to x. So how do you write it? Into d by dx of cos x. It is d by dx of, that is your cos x, right? So therefore, dy by dx is equal to 10 to the power log cos x into log 10 base e into 1 upon cos x into. Now what is the differentiation of that term cos x with respect to x? You know that, minus sin x, isn't it? So write minus sin x. So write on the final answer now. So dy by dx is equal to what? Minus, write it in the front. Minus, let us write sin x by cos x. What is sin x by cos x? It is tan x into, right? Minus tan x into 10 to the power 10 to the power log cos x into what? It is log 10 base e. It is log 10 base e. So this is the final answer. So is that understood? So dy by dx is equal to minus tan x, then 10 to the power log cos x into log 10 base e. So this is the final answer. So we'll do the next question now. So now we are doing the next question, that is 10 number 16. You have to find out the derivative of sin x degree with respect to x. So let us assume let y is equal to sin x degree. If this is given in terms of degree, you cannot differentiate it directly. This x degree that is in sexagesimal system, you should convert this sexagesimal system into circular measure in terms of radian. This degree, x degree, should be converted into what? Radians, right? So how will you convert this degree into radians? You know that 180 degree is equal to pi radian, isn't it? So radian is circular measure, you know that, and degree is sexagesimal system, right? So, or what is 1 degree is equal? Let us use the unitary method. So 1 degree is equal to pi by 180, and what's about x degree now? It is pi x by 180, right? It is pi x by 180, right? So therefore, what is y is equal to? This is your sine. What is x degree out here? X degree means pi x by 180. It is pi x divided by 180. Now you can differentiate it with respect to x, right? So write down, differentiating both the sides with respect to x. So therefore dy by dx is equal to dy dx of sine pi x by 180. Okay, so or let us find dy by dx now, which is equal to, how will you differentiate it? You should take it as x, sine x. You should take this pi x by 180 as x. That means you should take it as, first of all, trigonometric function is given, sine. So you should take it as sine x. What is the differentiation of sine x? Cos x. Okay. But here it is cos. What is x here? Pi x by 180. So this is not the only differentiation. Again, you have to differentiate the term which is assumed as x. हामीले कुन चाहिँलाई x माने लिएको हो, pi x by 180 लाई. त्यसलाई फेरि हामी के गर्छौं? Differentiation गर्छौं. That means dy dx of what? Pi x by 180. Is that clear? So it is, what is dy dx of pi x by 180? Pi by 180 is constant. You can take it outside. And what is dy dx of x only? That is 1, right? So or dy by dx is equal to cos pi x by 180 into, now here constant is taken outside d by dx. Pi by 180 constant is taken outside d by dx, isn't it? So now it is d by dx of x, right? So what is d by dx of x? It is always 1. So or dy by dx is equal to, now write down this constant term first, that is, so you should write down this constant term, pi by 180 first, that is pi by 180, then cos pi x by 180 into, what is dy dx of x? It is always 1. Okay, now what is the final answer now? Is equal to pi by 180 into 1 is pi by 180, right? Pi by 180 into 1 is always pi by 180. Then cos, you can write pi x by 180, or you may write x degree in terms of pi x by 180, isn't it? So since there is pi x by 180, here we have got pi x by 180 is equal to x degree. So you can write x degree instead of pi x by 180, right? So it is x degree. So this is the final answer. Now I'll give you the homework, right? So you can copy the question. So I'm giving you the homework now. So now these are your homework. This is from page number 291 and 292, right? So these are your homework. Exercise 3A, each question carries 2 marks. So you have to find out the derivatives with respect to x. So these are the questions that you can do it at home. Okay. So first of all, you revise all the problems that we did today, and it will be easier for you to do all these problems at home. Okay? त पहिला चाहिँ तिमीले के गर्नु, पहिला आज जति पनि हामीले प्रब्लमहरु गर्यौं त्यो सबै रिभिजन गर्नु राम्रोसँग, बुझ्यौ? जहाँ बुझ्दैन फेरि त्यसलाई रिपिट गरेर भिडियो रिपिट गरेर हेर्नु, बुझ्नु छैन? त जहाँ चाहिँ तिमीले बुझ्दैन तिमीले मलाई सोध्दा हुन्छ, मैले पहिला पनि भनिसकेको छु. You can comment me, okay, or you can give me the question number to do. You can write down the question number that you could not do, okay? So I'll do it for you. So these are your homework that you can do it. The पहिला चाहिँ तिमीले प्र्याक्टिस चाहिँ गर्नुपर्छ है, तिमी यहाँ गरेको हैन. यहाँ गरेको सबै तिमीले प्र्याक्टिस गर्नु अनि मात्रै यो सजिलो हुन्छ. बुझ्यौ? So find the derivatives with respect to x. That is 8 number 2, 2 cosec inverse 3x plus 3 cosec 2x, and all the functions are given here. So you should do it at home. Okay? So this much is for today. Okay? So you can copy it.